Dot point 1.1.2, there it is. This dot point is examined frequently. Here's a question that handles it comprehensively. This question also asks for information from a couple of other dot points. It's question 20 from the 2006 HSC examination. Analyze why ethylene is such an important starting material for the chemical industry. In your answer, include relevant chemical equations and a description of new materials and fuels that can be prepared from ethylene. It's a 7-mark question. First things first, ethylene is ethene is C2H4, all the same chemical. Let's take a look at the key elements of this question. We're looking at ethylene as a starting material in the chemical industry. The question is primarily asking, why is it so? But then it goes on and tells us a little bit about how to answer the question. It wants us to include chemical equations and a description of both new materials and fuels. Remember, we're thinking about reactions that start with ethylene, so forget about the production of ethylene itself. Now, my main answer is that ethylene can be transformed into many other chemicals because it's reactive. And it's reactive because it has a double bond and it can undergo addition reactions. I would elaborate on that answer with 3 examples, 2 materials and 1 fuel. In particular, I'd use high-density polyethylene, polyvinyl chloride, and ethanol, but you can choose any products from ethene. For each, I give a brief description of the production process, I give the chemical equation, and then a brief description of the product. So for high-density polyethylene, I'd say HDPE is manufactured when ethylene undergoes addition polymerization at 20 atmospheres of pressure with a temperature of 60 degrees Celsius and a Ziegler-Natta catalyst that mediates the reaction. Once the reaction starts via this initiator, the reactive double bond is used up bonding the monomers together into the polymer. Then I give the basic equation, then we describe HDPE. HDPE is a cheap and versatile plastic used to make plastic bags, pipes, and drink containers. Next is polyvinyl chloride. First, I'd explain that ethene can be converted to vinyl chloride, which is the monomer from which polyvinyl chloride is produced, and ethene can be turned into vinyl chloride via a substitution reaction. Then I give the general equation for the polymerization of PVC. Then we explain that PVC can be used as insulation, raincoats and shower curtains. And lastly, we have ethanol. Ethylene can be converted to ethanol via addition of a water molecule. Then we give the equation for the addition reaction. Don't forget that the catalyst is dilute sulfuric acid. Finally, we explain that ethanol can be used as a fuel, although currently we use biological sources for ethanol and do not manufacture it from ethylene for use as a fuel. So that's how I'd answer the question, to cover off all the keywords that were included and maximize my chance of answering what it is that the markers were looking for. Now let's have a look at how the examiners actually marked this question. Here's the marking guide for a full marks answer to this question. They were looking for the use of the key term addition reactions. They wanted information on polymers, even though they didn't specifically ask for that. They wanted 2 equations. Any more wouldn't get any more marks. So even though I included 3 equations and 3 examples, they probably would have just picked the best 2 and marked it on that. They wanted a comment on the double bond and its reactivity. And interestingly, even though they specifically mentioned fuels, full marks weren't contingent on the ethanol equation. So it's not clear what they were getting at with the fuels at all. Now, obviously, you won't get the actual marking criteria in the exam, you just get the question. So with long answer questions like this, you need to look at all the keywords in the question and cover as many bases as you can.